Hello everyone, today we're doing problem 6.28, and this problem asks us to draw the products of each of the following reactions following the curved arrow. So remember, curved arrow is the flow of electrons. So the base of your arrow is the origin of two electrons, and the head of the arrow is the flow where those two electrons are going to. Remember, the double-headed arrow represents two electrons, one on each head. So in A, we see that the base of the arrow is these two electrons, this lone pair electron on this alcohol ion, and we are attacking this carbon nucleus with two of those arrows. And now when we make a bond, we need to break a bond. So remember, that's a very important rule that we've gone over. When you make a bond, you need to break a bond. So what bond breaks? The bond that's bounded to the best leaving group. And here the best leaving group is any halide, iodine being included in one of them. So we made a bond, now we need to break a bond. So this is a concerted one-step reaction. This is what we call an SN2 reaction. Two arrows happening all in one step. Your nucleophile attacks, while your electrophile kicks off its leaving group. Remember, those two electrons in the sigma bond now goes to the iodine atom. In B, we see that these two electrons in this negatively charged oxygen comes down to form a new double bond, so that being your pi bond, making a new bond. When you make a bond, you need to break a bond. So the only three options is this methyl, this propyl, or this methoxide group. The ethoxide group. But obviously, oxygen being electronegative, it's able to hold on to these two sigma bond electrons more so than these carbon atoms. Why? Because oxygen is electron negative, it's electron loving, so it will hold on to those electrons better. It's okay being negatively charged. So the products we get plus our ethoxide that now has gained extra lone pair of electrons. In C, our nucleophile, water or hydroxide, picks up this proton using the nucleophilic oxygen with its extra lone pair electron. It's electron rich, making a bond. When we make a bond, we need to break a bond. So the sigma bond will break, forming a pi bond here. When we form a bond, we need to break a bond. So now the best leaving group here, obviously halides being very good leaving groups, so bromine will obviously leave. So that gives us and Br minus. So we get this ethane, water, and bromide anion. Chlorine here, so to see now we're dealing with one electron here. We're not moving two electrons, we're moving one electron. That is why we have half-headed arrows. So half-headed arrows mean the movement of one electron. So we're using one electron from this chlorine radical. We're binding it with a hydrogen radical, one electron from this hydrogen. The other electron in the sigma bond is going to the carbon now to form a new radical. So now if I were to draw the products of this, now we have carbon with its new radical, carbon radical, plus now HCl.